What is Synthesize and what are we doing in the Safe DevOps Health Radar when we are doing Synthesize? Please note that everything that I'm going to say and everything that I'm showing here is under the copyright of Scaled Agile. Please also note that the Scaled Agile framework is a framework. Use it as a toolbox where you just take out what you can need and what solves your problems. Synthesize is the last step of the continuous exploration in the Safe for DevOps Health Radar. In my previous videos, I showed you that the customer or also the business has ideas. These ideas are going to put into epics or epic hypothesis statements in the hypothesis step. After the hypothesis step, we are going to collaborate and research. So we take these epics, these hypotheses, and we are going to do market research, and we are also going back to the customer to find out what is really the problem of the customer or what is the need of the customer. With this information, we are going into the architect step, where we are going to do as much architecture that is needed to validate this hypothesis. After that, we are going into the synthesize step, because here we now need to synthesize all of this information so that we get a prioritized backlog. So what are we doing when we synthesize? In the synthesize step, we are creating a clear vision what we want to achieve. Of course, we also need to create a roadmap, so how we are going to achieve that, and of course for that we need to have a prioritized backlog. If we are a single team, then we have our team backlog. If we have multiple teams, then we have a program backlog. So why do we need to do this? At the moment, we have just a bunch of epics with hypothesis statements. Of course, we have identified the customer needs and we also did some architecture. But we don't have a clear vision what we want to achieve. And that's why we need to synthesize. It is absolutely crucial to have a clear vision what we exactly want to achieve. What is the future state? And this vision needs to really reflect the customer, but also the stakeholder needs. Such a vision needs to answer the following questions. What will this new solution do? What problem will it solve? And what are the features and the benefits it will provide? And for whom will it provide these features and benefits? And what non-functional requirements will it deliver? From the hypothesis step, we have these huge epics, which are significant initiatives, which will last longer than 3 months. They can also span over multiple years. We now need to break down these epics into features and also into enabler features. A feature is an item that fulfills a stakeholder need. An enabler feature is paving the way for further business functionality. So these pave the architectural runway so that we can deliver more business features in the future. A feature consists of a title, a benefit hypothesis, it has acceptance criteria and non-functional requirements. A feature should always be bigger than a sprint or an iteration. So if you have a 2-week iteration or sprint, then it should be bigger than that. It should also be smaller than, let's say, a quarter or 3 months, or when you are doing safe, then it should be smaller than a PI. And this means that a feature should always fit into a quarter of a year or within a PI. This is an example for a feature. The title is In-Service Software Update. The benefit hypothesis says that it significantly reduced the planned downtime. And then we have a set of acceptance criteria, which is automatic and manual update, rollback capacity, and all enabled services are running after the update. And as said, it has also non-functional requirements. Here in this example, availability of software updates is 99%. In the feature example before, we saw the acceptance criteria. One way of defining acceptance criteria is just having a sentence there or multiple sentences there. A better way to define acceptance criteria is to use behavior-driven development, BDD. I have created a video on behavior-driven development where I also use behavior-driven development in software development so that you can see how BDD really works. When you are doing BDD, then you write the acceptance criteria in the given, when, then form. Which means that given, we say this is the initial condition where we are at the moment. With the when, we are defining the action which we are doing. And with the then, we define what the expected result is. Behavior-driven development is a test-driven approach. So with this form, we already have the test which we want to have. So we create here in this form the acceptance tests already. And this enables us to get executable specification. Why is it important to have an executable specification? Because when you have your feature or your user story in Jira or in Word or in Confluence, then in the moment where you are pressing the save button, this specification is outdated. The only truth for a specification lies within the code. Therefore, it is important that we use behavior-driven development, is this given, when, then form, so that we can write out of that directly tests which we then can execute when we are doing changes of our software, and with that we are creating an executable specification. Here is the example that I used in my video about behavior-driven development. This is an example how such a specification or how such a feature can look like when we are using BDD. BDD can be used when defining acceptance criteria for features, but also for user stories. This here is the example that I used in my video for explaining behavior-driven development. It is a user story example. The user story says, as a user, I want to add 2 numbers so that I can see what the total is. It is about a calculator. The acceptance criteria for this user stories is, given I have entered the first number, which is 1, into the calculator, and I have entered the second number, which is 2, into the calculator. When I add these numbers, then the result should be 3. The benefit of using behavior-driven development is that the acceptance criteria is getting much more clearer, as you can see in this very small and simple example. So now that we have created all these features and also all of these enabler features, we need to put them into a backlog. As I said, when you are a small team, only one team, then you have a team backlog. If you have multiple teams, then you will have a program backlog. The program backlog is the holding area for all upcoming features or also enabler features, as you can see here. One important aspect is that it is prioritized, and as you can see down there, the non-functional requirements are a constraint on this program backlog. And this constraint applies to every feature and enabler feature in this backlog. So how do we prioritize such a backlog? SAFe has come up with the weighted shortest job first prioritization model, which ensures that we produce a prioritization with the maximum economic benefit. Weighted shortest job is also called WSJF in short. This technique will use the so-called cost of delay and divide the cost of delay through job duration or the job size. Cost of delay on itself is defined by the user business value plus the time criticality plus risk reduction and opportunity enabler. So how is this prioritization done? You have all of your features in a list, and then you will ask which one of these features has the lowest user business value of all of these features that we have in this set. And you will give this feature a 1 for user business value. Then you will ask which one of the remaining features has the same user business value, then you will give it a 1, or double, then it's a 2, or 3 times 3, or 5 times, then a 5. For the numbers, we will use the Fibonacci sequence. When we have done that for user business value and all the features have the user business value, then we will move on to time criticality. And again, we will ask ourselves which one of these features here in this set has the lowest time criticality, and we will give it a 1. After that, we will have a look at the remaining features and we will ask which one has the same time criticality, then it's again a 1, which one has the double time criticality, then it's a 2, and so on. And the same we are doing for risk reduction and opportunity enablement. Again, we ask which one of these features has the lowest risk reduction or the lowest opportunity enablement, and we will give it a 1. And then we will ask about the remaining features, which one has the double risk reduction or 3 times risk reduction. Now we build the sum out of that. So we will sum up user business value, time criticality and risk reduction and opportunity enablement for each feature, and this is then the cost of delay, and we will put this number in there. After that, we will go again over all the features and we will ask the question which one of these features has the smallest job size, and we will give it a 1. And then we will ask which one of these features has the double job size or the same job size or 3 times or 5 times the job size, and we will give them the corresponding numbers. When we have done that, then we will divide cost of delay by job size and we will get the WSJF. The feature with the highest WSJF number has the highest priority. This is how we do economic prioritization. Now we have created our vision, we have a backlog with features and enablers in it, and now we are able to create a roadmap. A roadmap is nothing else than a defined path how we are going to achieve our vision through implementing the features which we just have prioritized. We have different roadmaps. Of course, we have our daily roadmap where we are going to work on. Then we have our sprints or iterations. Mostly they are 2 weeks. And of course, then we have our quarter, our 3 months, the program increment. Then we have yearly roadmaps and 3-year roadmaps. A roadmap is very detailed when it comes to what we are doing today. It gets less detailed, of course, for the sprint or the iteration, which is roughly 2 weeks. And then we have also a less detailed roadmap for the next quarter, for the next 3 months, or for the next program increment. And then again, it gets less detailed for the year and, of course, for the 3 years. Up here, you can see an example of such a roadmap where you can see the different enablers and the different features which are developed over the months and of course over the years. And you can also see the significant milestones that we have. There can be of course something like a conference, or it can be a regulation that we need to fulfill. These are of course milestones which we are working towards them. The output of the synthesize step is that we have a clear vision what we are trying to achieve and what customer and stakeholder needs do we want to fulfill. Then we of course have a program backlog which is prioritized with our features and also the enabler features in it, and we have a clear roadmap, a clear plan how we want to achieve this vision. Of course, there is a great tool set out there which enables us to create these visions, this program backlog and also this roadmap. They are called Enterprise Agile Planning Tools. You can see that in here in this periodic table of DevOps tools. Of course, there are also other Enterprise Agile Planning tools out there, but this is just so that you get a good overview about the tools that you can use for this synthesize step. You can assess yourself in the synthesize step how good you and your team or your team of teams or your Agile release train is. Synthesizing involves combining the output of hypothesize, collaborate and research, and architect to produce well-formed prioritized features. These features then become the primary vehicle of value delivery through the remaining of the continuous delivery pipeline. Rate your team's ability to synthesize the results of continuous exploration activities into well-crafted, prioritized, actionable features backlog. You are a sit when the program backlog does not exist or is not shared. You are a crawl when the program backlog exists but the features are incomplete and prioritization is an afterthought. You are walk when the program backlog contains full defined features but are not prioritized using latest shortest job first mischief. You are run when features in the program backlog are complete, prioritized using mischief and calibrated to the delivery capacity of an Agile release train, which is an art. And you are a fly when the program backlog is a collection of minimal marketable features created using behavior-driven development and prioritized using greatest shortest job first. In the synthesize step, we are getting the epics from the hypothesis step and the market needs and also the customer needs from collaborate and research, and also the minimal architecture from the architect step, and combining all of that into a clear set of features which is then combined into a prioritized backlog or program backlog, and out of that we are creating a clear vision which we are going to implement on a roadmap. Now we are ready for the next quarter of the Safe for DevOps Health Radar, which is continuous integration. Now we will work on this feature and starting to develop. And with that, we are at the end of this video. Please leave me a thumbs up if you liked this video, and also don't forget to subscribe to my channel because I will create a video every week for you.